Hello everybody, I'm Rodrigo Tapia. I'm a researcher at the Delft University of Technology, and as an institution we are part of the Living Lab of The Hague. In this module I will present you our approach for the digital twin for The Hague. This lecture will start with a recap of the Living Lab to remind what are the objectives and what is our general idea of the Living Lab. Then I will follow to present the overall description of the Hague's digital twin. So which are the models that we use and how are they combined. Then I will illustrate this with a crowdshipping case. So which are the main assumptions and where do we get the main data from. Finally, I will provide some results of this crowdshipping case. As you might recall from the other sessions, the Living Lab of The Hague has an objective to recreate instances of hyperconnectivity. The first instance, represented by the minimal viable product 1, is the implementation of crowdshipping services. Crowdshipping services are a connection between passenger flows and freight flows in a way that they combine into one network. The second minimal viable product is the implementation of parcel lockers being fulfilled by a bicycle courier. These are two independent logistic service providers that will be combined through the API. Finally, the last minimal viable product, it's our vision of this Living Lab, is to create an open logistic platform where we can introduce connectors between loosely coupled systems first, and then to provide a full architecture supply. This is our main goal of the Living Lab. In the context of the lead digital twin, we'll have plenty of models in our model library. These are the main models that we are using to represent the different cases of the Hague. First, we start by generating the parcels that are involved in e-commerce. So we generate you mainly from population density data. We generate an amount of flows. In this case, it can be done at a zone level because since we don't know exactly and we're not representing exactly one particular day, the demand has some natural stochasticity. It's sort of random in a way. So it doesn't matter exact houses, but the general areas that they go. Then we feed this data into the parcel market model, where we do the actual fulfillment. In this particular model, we can simulate the effect of parcel lockers, how are they fulfilled, crowdshipping, which is the case, or hyperconnectivity in general, where different logistic service providers can share their networks. This data, specifically the data that are fulfilled by couriers, goes through the parcel tool formation. In this step, we take individual parcels that go from A to B into bundles, into actual tours, which are the main effect of the delivery system. We also have the shipment model, where we also generate trips for the fulfillment for example, supermarkets or other shops. These last two models go to the network assignment model, where we get the tours for parcels and for other shipments, and we load them into the network to understand where do they go and to obtain congestion KPIs. These models that I mentioned before are parts of the agent-based model MASGT. To obtain extra KPIs, we also connect these models with COPERT, where we get greenhouse gas emissions, or a noise model for the network assignment, where we get the effect of the noise into the different neighborhoods of the city. One of the use cases of this living lab is the first minimal buyer product, that is crowdshipping. What is the objective of the application of the digital twin here? Is to simulate the effect of commute-based crowdshipping. What is commute-based and why is this particularly important to highlight? Well, there is a possibility that crowdshipping can also generate new trips, but in this case, since our objective is to understand how different networks and systems are combined, in this case, passengers and freight, we only use commute-based system. What do we need to do this? Well, first, we need to understand the freight flows. These are modeled through the parcel generation model, and basic input are the socioeconomic. Then we also need the passenger trips. In this case, we don't simulate it within the digital twin, but we use data from the Albatros model, that is an activity-based model. From here, we get individual trips from different passengers all through the city. Finally, we need to understand how do people either send parcels through crowdshipping or accept being a crowdshipper, because it's likely that it will involve a detour for a compensation. But we need to understand whether this compensation is enough and to simulate this. These preferences are obtained through service and other type of preference studies. And how do we all model then the crowdshipping service is to engage all the different models that were presented previously. On the graph of the left, you can see how the demand of a parcel is fulfilled. First of all, we separate between local to local and interregional or international flows, because the local to local have also the additional element that has to be picked up in the city. But more or less over 95% is interregional. We can see on the right a zoom into the local to local, that is where the crowdshipping service is involved. Over 75% of the parcels are done by traditional couriers and the rest through crowdshipping. In this case, with this particular setting, all the parcels were matched, but for example, if the remuneration was too little, it can happen that some of them are unmatched and has to be fulfilled by the traditional couriers. Also, we can also see that most of the trips are done by car instead of by bicycle. This can potentially be problematic, but for this, we need to analyze a little bit further the results. Results that we can obtain through our digital twin is to understand how the remuneration works and influences the system. On the graph on the right, we can see the total amount of parcels that are shipped through crowdshipping through the different costs of the service. For example, we can see, as expected, when it's cheaper, more parcels would go through the system because more people would choose crowdshipping to send their parcel instead of traditional couriers. However, we can also see in the black line which is the expected remuneration for the platform from different levels. We can see that even though when the parcel costs 7 euros, the total remuneration is higher, because even though it's more expensive and less people use it, they take a larger commission. This would imply that for the platform would be beneficial to use a average remuneration of 7 euros. Analyzing another crucial KPI are the van kilometers. Overall, when the crowdshipping costs 7 euros, it's reduced by 3%. That brings us two scenarios. If these are replaced purely by car trips, then the total kilometers would increase significantly, and thus the greenhouse emission. This is because the cars would do such amount of detour that in the end there would be more kilometers. However, if this is done by bicycles, then the overall kilometers done by cars, which or are combustion engines, would be reduced because the parcels that before were taken by van, now they're taken by bicycle. This improves congestion and reduces the effect of greenhouse emissions. As a summary of what we've seen today, first we show the objective of the digital twin, and that we want to represent how the logistical platforms are connected and implemented and creating this hyper-connected network. Then we detail the case of the crowdshipping case, where we explain how are the models run and which the combinations to obtain relevant KPIs such as the total kilometers done by the logistics system, the amount of driven kilometers, the greenhouse emissions, the expected remuneration by the crowdshippers, and the expected total revenue by the platform, and we are able to simulate the effect of different prices. Well, this has been all for today. Please don't hesitate to contact me if you have any doubts regarding what has been explained today, and also visit the website of the LEAD project in order to have up-to-date news on the Living Lab.